Okay, we have numbers and numerals, enumeration and notations. We have the next topic is rounding, approximation and estimation. Rounding, approximation, and notation. Rounding, approximation, and the estimation. Sorry, not notation. And the estimation. And number 4, we solve questions on ratio, proportion, and variation. Ratio, proportion, and what? Variation. Number 5, we have pharmaceutical measurement. Topic 5 is pharmaceutical measurements. Then the 6th topic is dosage calculations. Dosage calculation. Then the 7th one is reduction and enlargement of formulas. Reduction and the enlargement of formulas. Then the 8th topic is density. The 8th topic is density, specific gravity, and specific volume. Density, specific gravity, and what? Specific volume. The 9th one is concentrations. The 9th one is concentrations. The 10th one is dilutions. Then the 11th one is isotonic solutions. So this is what we look at in PharmCalc. Because of time, this is a revision. Because of time, I may not start teaching the topics again. We have done it. So what I will do is this, as I said before now, I will solve one, like now, each time I come to the class, solve one question in numbers and numerals. Enumeration, this is how we're going from one topic to another topic. Maybe by the time we spend 1 hour or so, I would have solved all the questions, one question from each of the topics. As we are solving the question now, other things, it will start exposing some certain things. If you have question maybe from what you are solving, that question can lead us to discuss 1 or 2 things. So I want our revision to be question oriented. That is the fastest method to do what? Revision. Question oriented. So we'll start by picking questions. And let me attend to. Okay, so we are not alien to these topics. These are topics we've digested in your second year. Solve as many questions there, and you were able to pass the course. So it's not a new thing to us. So I want to pick a question in numbers and what? Numerals. With that, we can take it off from there. Now let's look at this question. The first question in numbers and numerals says There's a list of number here. 3i, comma, 2 plus 4i, comma, 9, comma, root 7, pi, comma, 22 over 7, 1 over 8. Comma. After 22 over 7, after pi, comma, 22 over 7. Then, comma, you have 1 over 8. 1 over 8, comma, 1 over 3, comma, 0, comma, minus 4, comma, and 7. So the question says, choose examples of the numbers below from the figures listed above. You know, we listed some figures above now. So you're now asked to choose examples of the numbers below from the figures listed above. So the numbers we want to list now is, number 1 is complex number. What it means that, look at these figures above and write the one that is a what? Complex number. Is it clear? Then complex number. Number 2, imaginary number. Imaginary number. Number 3, discrete number. Discrete number. Number 4, continuous number. You know, it can be one number or more than. So the best thing is to put, after writing that number, you put in bracket S. That means number or numbers, because you may have more than one in the list. Is it clear? You may have more than one complex number in the list. You may have more than one real numbers on the list. So you list all the real numbers on the list. That's the meaning. Now, we are desktop. Number what? Huh? Then we have discrete rational number. Discrete rational number. Then rational number. Rational number. Number or numbers. Irrational number in bracket S. Irrational number in bracket S. Number 9. Continuous rational number in bracket S. Continuous rational number. The first one is continuous discrete. This one is continuous rational number. Then number 10. Who? Have I called number 10 before? Okay. What I call as number 8?
Continuous rational.
Number 7, Uncle?
Irrational number.
Okay, 7 is irrational number. 8, go up. 6 is what?
Rational.
6 is what?
Rational numbers.
The 6 I have here is discrete rational number. Discrete rational number.
Number 1 is complex number.
Yes.
Number 2 is imaginary number.
Yes.
3 discrete number.
Yes.
4 continuous number.
Chalo? Start all over again.
Complex number 1.
1,
Imaginary number. Discrete number.
Yeah, that's where the problem came from. 3 is real number. Real number, yes. You can the order is not important. Do what is to get the answer. The order is not important. So that's where the problem came from. Have I called irrational number? Then you start with continuous rational number. Have you written continuous? Then next one is whole number. Okay. It's in matter. Okay. Just leave the number. Just leave the. Just focus on the what they are told to us to find. Have I called whole number? Natural number. Natural number in bracket S. Then integer in bracket S. Integer in bracket S. Prime numbers. Prime numbers. Good morning. Good morning. The number, okay, forget that. No, the next one is odd numbers. Odd numbers. And the last one is even numbers. Even numbers. The last one is even numbers. Okay, so the question is that we should look at the numbers listed now. Now, check from that number, at least the ones that are complex number. It can be 1, it can be 2, it can be even more than. So you must list all of them. You don't need to stop because there's a limit. The numbers listed are limited. So you should be able to identify all the complex numbers in the list. Identify all the imaginary numbers in the list, real numbers till the last one. So that's what the question is all about. So this, if we are able to answer this question, we would have at least covered something in numbers. Maybe when we come for the second round, we can now touch what a question has to do with what? Numerals. Now, complex number. You know, what are complex numbers? Do you remember? How many years ago? 2 years here? You should remember it. So what are complex numbers? What are complex numbers? Success. Tell us. What are complex numbers? This revision, I am only a moderator in this revision. It says pre-certification exam revision. I am only moderating it. Oh yeah. What are complex numbers? Anyway, I told you that this is not our. It's just for you to know that such number does what exist here. I say that the number we know we use on our daily basis is that what natural what numbers or real numbers. Let's say real numbers. Are we together? That's one we know. So we have real numbers and we have imaginary numbers. Am I communicating? We have real numbers and we have imaginary numbers. And if you can remember, real numbers is the one we know. We use on our daily basis in our calculations. Then, but imaginary numbers, that one is used mainly in the computer engineering, whatever this thing. But just know that such number exists. The number is represented by, you see something like this. And I tell you, what is the value of this? Root what? I is root what? Root what? Root what? Root minus 1. Let us not go. Just for you to know that it exists. But when you see that a complex number contains both real number and what? Imaginary what? Number. Am I communicating? A complex number contains both what? Real and what? Imaginary. So a number in this form, A plus B what? I is a complex what? Number. This A part is real number we know. Is it what? The real numbers we do what? No. What of this BI? This BI now, this is the what? This is the imaginary part. Remember I told you that this I is with what? Minus 1, right? So that means if you have, you know, in your normal calculation, if you punch your calculator and say root 2, root 4, your calculator will tell you error. True of us? Have you tried it before? Your calculator will tell you what? Error. But if you come to this area now, this actually means root minus 1 times what? Root what? 4. True or false? You remember your sword. Root minus 4 is root minus 1 times root what? 4, right? So this root minus 1 is what? This root of minus 1 is what? I, right? Times what? Root 4 is what? 2. So this is actually what? 2i, right? Let's not go there. Let's not just for you to know that such number exists. This is actually, so in that area, if you are asked, after solving calculation and you go to level of square root of minus 4, it will end up to a what? 2i. That's the meaning. Now complex number is in this form, right? So from these numbers, which of them is a complex number? 2 plus 4i, right? For number are listed. Those that came late are listed some numbers. So we are picking these numbers from them. We are listed some numbers. We are picking these numbers from them. So from the number we listed now, a complex number there is what? 2 plus what? 2 plus what? It's not in this form. It's not in this form. So if you actually want to convert this to retain the root sign, what should be this? What should number this thing actually mean? If you should retain the square root sign, sorry. Or is it root 4? This should what? Root what? Root minus what? See.
Root 2.
Okay. It's okay. Oh yeah. Linear now. This is now say this root minus square root of minus 16 is certain as if you expand it, you have root minus 1 times what? Aria. Is not? Is root A times root B is what? Aria be here. Aria. So that means root minus 16 is what? Root 1 times root minus 1 times root of what? 6. Aria. But this one is what? 4. Square root of 16 is what? 4. But square root of this one is what? I. Agreed? So I times 4 is what? 4i. Don't worry. Just know that we have what? 2 plus what? 4i. Now, the next question says that we should identify what? Imaginary number. So which of them can you imagine number did that? 3i is imaginary number. So 3i, or return the square root. 3i is what? Root of what? Minus 9, good. Root what? Is it clear? Because if you split them now, it becomes root minus 1 of minus 1 times root of 9. And root of 9 is what? 3. Root of minus 1 is what? I. It becomes 3i. So the imaginary number is what? 3i. Any problem? I'm saying now, you know that we say that. I told you that when it comes to imaginary number, I actually means this thing. Or you mean? So if you have 3i, what it means is, if you have 3i, this is actually what? Minus what? Are we there? 3 roots minus what? 1. But if you want this root to disappear, remember this will become what? Squared, right? Right? So we have what? 9 what? I. Is it clear? Is it clear? Now let's go, please. Let's go. Now, next one says real numbers. Pepe, okay, now what? I just for you to identify this. Let's just go. Nobody is bothering with those ones. I just want you to know that this exists, because you don't know where you see yourself tomorrow. Now, what next one is real numbers. This is where the game starts. Real numbers. What are then these real numbers? What are they? For the name real numbers, these are actually the numbers we know. These are the numbers we know, the one we use on our daily basis. True or false? Now, I said, what are the real numbers now? Real numbers is the mother of all numbers. All numbers are under real number, apart from complex number. All the other numbers, is it whether it's integer, whether it's whole number, whether it's natural number, whether it is what is it called again, even number, whether it's odd number, whether it's prime number, all these things are under what? Real numbers. So from this now, which one here are the real numbers? 9. Just simply remove complex number and what again? Just remove complex number. Others are real numbers. Period. Just remember, I told you that numbers is very into two. We have real numbers. So under number we have real numbers and complex number. So under complex number, I told you that complex number contains or simply say real numbers and the imaginary numbers. Forget complex numbers. Forget complex number, because complex number is formed from combining real and what? Imaginary. True or false? So that means under numbers now we have what? Real what? Numbers and what? And what? Imaginary. As in imaginary, they just imagine it's not that it's real. Imaginary number. That's why you see that are we together? So these are numbers that are already into this race. So all these ones, whether they are complex, imaginary is I told you about I, right? But when this I combine with a number from real number, it becomes a complex number. So we talk about this imaginary. Real numbers are here. So in that list, once you remove the complex number and the imaginary number, the remaining one is what? Real numbers. So, and from this list now, the imaginary number there is what? 3i. And complex number there is what? 2 plus 4i. The other numbers there are what? Real numbers. 9 is a real number. 2 is a real number. Root 7 is a real number. Pi is a real number. 20 over 7 is a real number. 1 over 8 is a real number. 1 over 3 is a real number. 0 is a real number. Minus 4 is a real number. And 7 is a real number. This are real number, but all those I and the 3i and the, what is it called again? And that 4 plus, they are not real numbers. They are complex. They are imaginary and complex numbers, respectively. Now let's go. So the next question says, what are discrete numbers in the list? I think it's better I list for those that came in. Let me list those numbers so that as I'm talking, they are looking at me like as if they are lost in Sambisa. Let me list those numbers so that as we you call them for me, let me not waste my time. Call them fast. 3i. 2 plus what? 4i. 9. Root 7 are there? Okay. 5. 22 over, okay, pi, sorry, not 5. Pi. 22 over 7. 1 over 8. 1 over 3. 0. Minus 4. And what? 7. Good. So we say that this is an imaginary number, right? This is the only imaginary number there. This is a complex what? Number, because it has a real and imaginary what? Number. True or false? Now, this one is gone. Then the real numbers start from here. All these ones are what? Real numbers. Now the next question is, discrete numbers. Now, remember when we did this course, we talked about continuous numbers and what? Discrete what? Number. Now, under the real number, we have the continuous and the what? The discrete. Now, I define that discrete numbers are numbers that are just there. Bam. This is what it is. There is no. It doesn't extend maybe to another. There's a clear cut that this is where this number stops. If you have 0.1, it's 0.1. It stopped there. Then like it's not. You not approximate it to get to get final answer. In a calculation, there's some numbers you 0.033 before you can get the answer. You do what? Approximate. Once you are done, it's 0.1. It's 0.1. Even though it's not a whole number, but it's a discrete. It's just there. Bam. They're not like 0.11. Okay, I can measure in 2 decimal places. No, it's 0.1. If it is 0.5, you cannot have. If it's 0.165, is what? 0.165. They are not. You didn't get it out of approximation. If it is 0.25, if you divide 1 by 4, it's 0.25. It's 0.25. You did not get that by approximating it. But if you divide 1 by 3, you get what? 0. What? 33, right? 33. Before you can say, okay, let me now approximate and stop at what? 0.3. 0.3 is not a discrete number. It's a continuous number. 0.25 is discrete. It's there. 1 is discrete. 2 is what? Discrete. So now, from this list now, from what I described now, which of these numbers can you say that are discrete numbers? Discrete number is what of a discrete number? Divide 1 by 8. What's the answer? 0.125, right? Is a discrete number. It's discrete. 0.125 is a discrete number. 1 over 4 is 0.25. Divided by 2 again. 0.125 is discrete. Now, what else? 20, is it a discrete number? It's not. It's a continuous number. It's not discrete. You must approximate it before you can stop to a particular what? Decimal place you want it, or significant figures. It's a what? Continuous. It's not discrete. What of 7? 7, is it discrete? Yes. It's well, of course. This one has no issue now. This one is discrete. Is what? Discrete. 0, is it discrete? Yes. It's discrete. 1 over 3
No.
Is 0.3333 is continuous. In fact, you won't even know where it has no end. A continuous number has no ending. It linked to another number. You cannot know where it stops. So this is the continuous. It's not the discrete. 2 by 7 is what? Continuous. It's not what? Discrete. So discrete numbers here are what? 7 minus 4, 0, 1 over 8, 9. Good. Root 7 is not a discrete number. Now, the next question says the continuous numbers there are what? That is clear. 1 over what? 3. 20 over 7, pi, and root what? 7. Those ones are what? Continuous. Now, under discrete, next question says, which one are discrete rational what? Numbers. Before we go to discrete rational numbers, I want to talk about what are even rational numbers. I didn't want to ask you rational number. I just want you to discrete rational number and continuous rational number. Now, let's talk about what are these rational numbers. What are what? Oh, yeah. What are rational numbers? Tell us. Fast. If Canada. Hope your promise, I don't forget things, so but your promise is still here. He's still here. Image channel if you look first here. I have What are again in Kedafia?
Rational.
Rational numbers. Just simple. Just know. Just tell me. Just understanding. Don't know the future. Just understanding. What do you understand by rational number? No idea. Now, from rational came from the word ratio. So rational came from ratio. So any number that can be expressed as a fraction in this form, A over what? B, such that A can be what? 0 or any integer. B can be any integer but cannot be what? 0. Is a rational what? Number. To put it simply, rational number are what? Fraction. Common what? Fraction. Period. So rational numbers are common what? Fraction. Am I communicating? Now, when you have not every number that in this form is a rational number. Are you aware? 22 over 7. So I mean, not every number that has decimal point is a rational what? Number. Some numbers may have the decimal points, but they are not what? Rational what? Number. So rational numbers have decimal point. If you change it to the decimal fraction, they have decimal points. But not all numbers that have decimal point are what? Rational numbers. I will explain that. But I just want to have just a short description of what rational numbers are. Now, let's go down to that. Discrete and what? Continuous rational number. With this explanation now, what is a discrete rational number and what is a continuous rational number? From our definition of discrete numbers, we say that the value is just definite. They are nothing like continuous to another number. There are some fractions that are what? That are what? Discrete rational. That if you divide it, you get the answer straight. So most fractions that lead to terminating decimals, we mentioned terminated decimals, right? In your second year. Fractions that have terminating decimals, they are discrete what? Rational numbers. Example. Something like 0 divide 1 over 5. What's the answer? 1 divided by 5 is what? 0.2. 1 over 2 is what? 0.5. 1 over 4 is what?
0.25.
1 over 3 is what? 1 over 2 over 3 is what?
0.666.
Now, watch these numbers. All of them are fractions, right? True of us. All of them are fractions. But not all of them are discrete. Some are discrete, some are continuous. Look at this 1 over 5. 0.2, it stops here. It's a discrete rational number. 1 over 2, 0.5, it stops there. It's a discrete rational number. 1 over 4, 0.25, it stops there. Like nothing like continuous. But watch 1 over 3. 0.3333. If your calculator, if the length of your calculator starts from here to this point, you start that train will continue. It can never stop. So it depends on the size of your computer or your calculator. It continues. So it's continuous. It's not what? Discrete. The same thing with 2 over 3. 0.66666 is continuous. So these ones are continuous rational numbers. Why these ones are what? Discrete. So from this question, which of these now are continuous, are discrete rational numbers? What about what? Cosa? Cosa? I agree with you. Okay. Just list. Just list. No, first one is what? I agree. We are talking about this. Okay. And another one is what? I agree. Don't worry, calm down. Be coming down. Don't worry. I will talk about it. I will explain that. I agree. I agree. What else? 7. I agree. Cause Augustigo. Someone said that. Kenkis that you don't agree.
4 minus 4.
That's sure. Now, let me explain. I said that rational numbers are numbers that can be expressed in the form of A over B. A is an integer, including 0. But B is an integer, but not with the exception of what? 0. So now, with this definition now, 7 is 7 inclusive. It is, because 7, this 7 you're looking at now is saying 7 over what? 1. So it's a rational number. Is minus 4 included? Minus 4 is an integer. Minus 4 is an integer. Integer contains both positive and negative side. So minus 4 is an integer. So minus 4 is stated as saying minus 4 over what? 1. So it's a rational number. 0 is an integer. So 0 over anything is what? 0. So it's still what? A rational number. Correct? 9 is something. So these ones are what? Discrete what? Rational what? Numbers. Now, next question says what? Rational what? With what I explained about rational number now, you can check those that are rational number. Is this a rational number? 7? Minus 4? 0? 1 over 3?
Yes.
1 over 8? Yes. 20 over 7?
Yes.
Pi?
Yes.
Is pi a rational number?
Yes.
Is pi a rational number?
Yes.
Minus 7 is minus 7 a rational number? Sorry, root 7. Yes or no? Is 9 a rational number?
Yes.
Now let me explain. Pi, hello, know it today. Pi is not 20 over 7. Motiatata. Before. Forget if I go to primary school. Take pi to it. What I say? Pi equal to 20 over 7. Lie. If you think I'm lying, punch the value of pi in your calculator. Write it out. Just use the calculator. Check the value of pi. Write it out on your book. In your book. In the China. Then you punch 20 over 7. Compare the two of them now. Then you understand what I'm saying. No, your phone can do that. Your phone calculator can do that. Yes, use your phone calculator. You can check it with your phone calculator. What they did in your primary school is that your primary school, or your secondary school, they just look for a number that will be close. If you approximate it, they will look alike. As if you're assuming it, but pi is not 20 over 7. For real.
It's a rational number.
Pi is a rational number. Check them. No, I will talk to you. I will tell you why pi is not rational. Even though the value has that decimal point, it's not a rational number. I'll tell you why it's not a rational number. I'll tell you why 22 over 7 is a rational number and pi is not a rational number. So they are not even related. But all those things they are just doing as assumption. Who has punched the value of pi? Write everything. Then write everything. Don't abominate. Just write everything you see in your phone.
Everything here.
Yes.
Jesus.
Just calm down. Do it first.
3.14159266.
I want to use this to explain two things. To tell you that pi is not the same thing with 22%, and also to prove to you that pi is not a rational number. Why 22% is a rational number? Just have you listed the value of pi? Now point 22/7. Compare the two of them. Have you checked it? Okay, now someone should call for us. Hope you've taken down these topics. Now someone should call for us the value of pi. As you call, I write it down. As you call, I write it. So pi, let's go. Pi is what? 3 point. Louder, please. 3.1 person. 3.35 what? 9 what? I'll go. Then 20/7 is what? I say don't approximate. 5 what?
589.
Then punch 20/7 is what? 3.14. Calm down. There's something I want to point out here. Let's do it slowly. 142857 what? 1428 what? 285 what? Let's stop here. Look at these two numbers. Hello, look up please. See pi 3.14159266. Then see 22/7. From after this first two decimal places, they're not the same thing. That doesn't mean that they're the same thing. I want to explain something. Remember I told you that pi is a rational number. Sorry, 22/7 is a rational number. Why pi is not rational number? That's what I want to explain now. The first place, their value is they're not the same thing. They don't have the same value. That's number one. But at the level of your primary school, they just stop here. When you go to serious calculation, you don't do that. If you go to advanced calculations, you don't do that. They're not the same thing. That one apart. Now, pi is not a rational number. It's an irrational number. But 27 is a rational number. Now let me now explain. Now, in this fraction, in decimal form, I want to distinguish between rational number and irrational number. Look at it. A decimals of a rational number has a pattern. Decimals, that's number one thing you should know about a rational number. Decimals of a rational number have what? Pattern. It can be up to 3. It can repeat itself after like 3 digits, or only one digit will be repeating itself to the end. We call it recurring what? Decimals. It can repeat itself, maybe 0.333. It repeating itself, just that one. It can be after like 4 digits. It will start afresh. That one is also a rational. But irrational is scattered. There's no pattern. Look at this thing now. Look at pi. From here, is there a pattern?
No.
It's scattered. So pi is an irrational number. Look at 22/7. Look at after 142857. It stops here and starts all over again. After like 1, 2, 3, 4, 7, it starts all over again. The same thing will continue. 1, 4, 2, 8, 5, 7. Let me tell you the truth. If you take this number from here to the end, once after 7, 4, 1 will start again. 1, 4. This is what we see in pi. 1427 142857. Again, it will start again 14. So pi has a pattern. Sorry, 22/7 has a what? Pattern. 22/7 is a rational what? Number. But pi is not a rational what? Number. So from the question, the rational numbers there are what? 7 minus 4, 0, 1/3, 1/8, 2/7, nke abụọ, 9. Are we together? Now, root 7 is not a rational number. Remember in your sword, they will tell you that you want to rationalize a sword. A sword is not a rational number. Pure ED. A sword is not a rational what? Number. A sword is not a rational number. So root 7 is a sword. It's not a rational what? No. Point root 7. Is there a pattern there?
No.
It's scattered. There's no pattern. Is root 2 a sword? Root 2, is it a sword? No. Root 2, you know where? You are tired already.
No.
Is root 2 a sword?
No.
Yes, no. It's a sword now. Does it have a pattern?
No.
It's irrational. Is what? It's irrational. Now, let's look at the next question. It says, what are the irrational numbers? So what are the irrational numbers there? Pi and what?
7.
And root what? 7. These are the irrational numbers we have there. Yes, root 6 is a sword. Root 6 is a sword. Now, what of the question now says, the next question says, continuous rational numbers. Continuous rational numbers. So what are the continuous rational numbers here? And what? And what? Is pi a rational number? I said continuous rational numbers. Good. 22/7 is rational number and it's continuous, right? Yes. And so the answer is what? 1/3 and 22. Even 1/3 has a pattern, right? Yes. But it's not the same pattern with this. It repeats after one digit. That same digit is repeating itself. But this one, after like 4 digits, it repeats again. True of us. But both are what? Rational number. And they are what? Continuous. Now, the next question now is the whole numbers. What are the whole numbers then? You get to know what is the whole number first. Before you were Zavan gave whole number. What are whole? Okay, list it. Tell me the whole numbers. 9, 0. Nke a gụnụ na-egwu akwụ na-egwu na-ede anyị take you ma eziokwu. Anụ m 9, nụ 7, nụ 0. What else? Agwụsigo? 1/8. Anyị akara mmadụ nke bụ eziokwu ka anyị na-egote mesị ya mgbe na-akpọ nụ ngwa agwụsigo. Now, what are whole numbers? Let's start from there. What are whole numbers? Okay, now let me break down real numbers. Under real numbers, now you start having, under real number, now you have what you call integers. Hello, are we together? Yeah. Under real numbers, we have integer. Real numbers real numbers can be represented in the what? This number line now. Real numbers are in the what? Number line. But there's something there I want to point. In fact, let me use number line to explain all these numbers once and for all. So we can now conclude this number one. It's taking us time. Let me draw number line. This is a number line, right? Now here we have your what? Neutral, which is what? 0. Everything here is what? Negative what? Infinity. To what? Positive what? Infinity. So all numbers here are what? Positive. Numbers here are what? Negative. Now we have here. Hello, are we together? Are we together? Here we have 1, 2, 3, 4, 5. Where the gabas here? Here we have minus what? Minus 3, minus 4, minus 5, minus 6. Where the gabas here to the what? Negative. Now look at this. This is a number line. This is a number line now. All this number line contains a lot of things. This number you are seeing here contains. So I want you to describe integer. Describe integer. In fact, all these numbers I've been calling here since. I use number line to do what? Describe it. So everything on this number line, are what? Ray what? Numbers. Are we together? All these numbers here, between 1 and 2. I work a number between 1 and 2. What's okay, yeah? Forget that you are seeing 1 and 2 here. You go 1, go 2. No. A lot of numbers are here between 1 and 2. Now let's keep it there. Now, look at these numbers now you are seeing here. Monkey, both the one you can see here and the one you cannot see here are all what? Real numbers. But the ones you can just easily look at and see and present without issues, they are the what? Integers. This one that you are seeing, you can easily write, represent on this are integers. You have your what? -1, -5, 0. These things are what? Integers. Are we together? They are what? Integers. Now, under this integer now, we have what we call what? Natural numbers. Are we together? Now, hello. Now, we have natural what? Numbers. We have what? Whole what? Numbers. Now, what difference between natural numbers and whole numbers? Natural numbers are the counting numbers we know. Hello? Natural numbers are the what? The counting what? Numbers we know. Natural numbers are the what? Counting numbers. Then what is a whole number? Any idea? Oh, you have to tell us. Is 0 a whole number? Is 0 a whole number? Is 0 a natural number?
Yes. So natural numbers are counting numbers. You can count 0.
Hello? Okay, now. From here, from negative to here are what? Integers, right? Yes? Good. But from 0 to the positive side are what? Natural numbers. From 0 to the positive side are what? Natural numbers. Natural numbers. From 0 to positive side are what? Remember, from negative infinity to the positive infinity, the one you can easily represent in your number line you are seeing, not the one that is hiding between this number. They are the what? Integers. But from 0 to the positive infinity are the what? Natural numbers. Now, why from 1? So whole numbers are natural numbers with the exception of what? 0. Whole numbers start from what? 1 up. Remember, those inside here are not what? Inclusive. Is this one you are seeing? 1, 2, 3, 4. So -4 is not a whole number. Are we together? So that means 1 up are what? Whole numbers. Are what? Whole numbers. Are we together? Are whole numbers. They are what? Whole numbers. Remember integer. Integer gave birth to all these numbers I'm calling now. True or false? Good. Now, After that, let's look at prime numbers. What are prime numbers? Ta-da! What are prime numbers? Who will save us? Pepe Oya. What are prime numbers? They are numbers that can be divided by what and what? And itself. Good. Example of prime numbers are what? 3 cannot be divided by 3 and 1. 3 of us. 3 divided by 1 is what? 3. 3 divided by 3 is what? 1. What else? Is that a prime number? 5, right? 5 divided by 5 is what? 1. What is minus 5 a prime number?
No.
Yes. Yes. Remember I said that integer give birth to all these things, right? So minus 5 is a, because minus 5 can be divided by 1. Minus 5 divided by 1 is what? Minus 5. And minus 5 divided by minus 5 is what? 1. It's not erase. Erase, right? Good. So now, what are even numbers? What are even numbers? Are even numbers? So what are the even numbers there? Hey. 0. What are even numbers there? Zero and what? 0 and what? Minus 4. Okay, 2 is not here. There should be 2 here. Sorry, I didn't mention 2. What are the even numbers there? 0. Someone asked, how is 0? What did it define as even number? So 0 divided by 2 is what? 0 divided by 2 is what? 0. What else? 2 is an even number, right? 2 divided by 2 is what? 1. Minus 4, is it an even number? Yes. Minus 4 divided by 2 is what? Minus 2. Good. Now, what of odd numbers? What are odd numbers? Is it true? What does it mean? You're hinging. So what are the odd numbers here? 7. 7 and what? 7 and 9. Remember, I said that integer give right to these numbers we're talking about. Is total 7 an integer? No, it's not. True or false? It's not an what? Integer. Hello? Good. Now, I think we have dismantled this question. Is there anything that is not here?
So integers here is
integers are these are the integers. But real numbers are except the imaginary and complex numbers. So we have refreshed our memory on what? Numbers. Now let's go to the next. Remember we say we look at topic by topic. Let's see we can do 1 or 2 things in what's time? Can you improve question when I ask? Okay, ask. Meme inform. Go to Atram. Which group are on? NPCE. But we have our own group. I better goon and goon. I want our own group, we don't want each. So in about the people say before they started they started posting in a group for 1 week. Never check how kuku. That's why it delayed before you enter their own group. That was presented since almost 1 week ago. Before that day, unfollow. I only go 1 week. A post yourself in our own group. Never check for comment from different lecturers because some people may not come to online in a particular day. Some may come at least that grace have been given. So have you tried calling her?
I did not call her. That's the thing that
Your issue. I told you something now. There's something I told you. I'm not supposed to be telling you this, but at this level, I think I should explain certain things to people at this level. You are not the one to speak for the lecturer. Lecturer has to do what? Speak for him or her what? Serve. This table you are seeing here was not just prepared and rushed we are put to you. It passed through stages. It wasn't just prepared and you see it bam in a group. No. That's the point I'm making. So when you say charge on Tuesday, it my guesses. So that one have issue. Issue. So let's continue with what you are doing. Okay, issue. All right, so let's continue. Okay, let's see what we can just look at. With one or two things on enumeration and what notation. Now, under this topic, enumeration and notation, that's where you start seeing different ways these numbers we've been talking about can be what represented. Different what ways. You can see it in different forms. You can use forms, notations. You can see it in what form of a fraction. True of us. You can see it under as a fraction. You can see it as a what whole number. Even under fraction, you can see it as decimal fraction. You can see it as what common fractions. We discussed these things in your second year. You can also see it as percentage. Percentage. You can see these numbers as what? Percentage. You can also see it as what? Decimal, as in standard form. Standard form. Or scientific what? Notation. Or what? Scientific what? Notation. You call it standard form or you call it what? Scientific what? Notation. You can also see it as ratios, even though we still do ratio as a topic. So this is what this topic is different about. This way you start seeing percentages, calculations in percentages, fractions and the estimation. Percentage fraction and the decimal fraction, common fraction, percentages mainly. That's what you see under this topic. So question we are going to solve here has to do with this area. So no need trying to telling you convert 1/2 to decimal fraction. Those ones are not questions. Let's look at practical oriented what question. Question has to do with or telling you to convert 1/8 to percentage. Who that one is too direct now. You can do it easily, right? Just punch times 100 answer. So those ones are not question. True of us. So I don't think those ones are question. Let me test us on this. Let's check which of these numbers, the highest number in each of these. 4.1, 4.01, 4.001. Which of them is? Let me test you this thing here. The highest among these three numbers, 4.1, 4.00, 4.01 and 4.001. 4 point what? 4.1. Okay, if you see. Here I have a question. Block question here. It's 4.1 now. Okay. or telling you how to multiply standard form, all those things. Those ones are not that clear. Let me look at practical oriented question. Okay, as a question. Okay, let's look at this question. We have we're cleaning. Let's look at this question. Put in bracket 3.6 times 10 to the power minus 2. Bracket closes. Open a bracket. 3.6 times 10 to the power minus 2. Bracket closes. Then times. Open another bracket. Put times and open another bracket. 2.5 times 3 to the power 6. What's the answer? These things are easy now. What's the answer? 9 what? I come and solve it on the board. Let's see what you did. So come and solve it. Let's see what you did. Fast. I don't see these things as question. I'm going to practical related question. I want to use names of drugs to just ask questions that has to do with practical related, not the resistance. So times 2.5 times 8 plus 6. Okay,
Okay. Equals to 9. Sorry.
So tell us what you did. I want to know what you did. Just explain what you did.
Okay, it's 3 times 3.6 times 2.5
is what?
Equals to 9.
Okay.
Raised to power 10, 6, 9. That is minus the power.
Okay, it's okay. Thank you. So what is this? This is simple. You just this is a standard form of scientific notation. Just simply multiply these two numbers, right? Remember, the law of indices will come here. Will come into play here. Law of indices, this and this are the same thing. So you use one, take one out the 10, then the one at the, since here is multiplication, what will be at top should be what? It should actually be addition, right? But because this is negative, it eat up the plus sign. You have 6 minus what? 2. That's why you have what? 9 times 3 to the power minus what? 6 minus 2, which is what? 4. It's simple. You say, okay, now let's change this to addition. Let's change this to plus sign. Okay, let's assume here is division. Let's start with division first. Let me rush through it. What should be the answer? Division. What should be the answer? Tell us. Just tell us what you should do. It's okay. Divide what? Divide what and what? By what?
3.6 divided by 2.5.
Good.
Minus.
Okay, so this is it will become something like this. Use this number will be divided by what? 2 point what? Up here? Times what? Bring out this 10. This becomes minus 2 minus 6. This becomes what? This divided by this will give you what? 1 point what? 1.4 times 3 to the power what? Minus 2 minus 8 is what? Minus 8, good. Minus 8. So the law of indices comes into play here. Law of indices comes into play. Now let's assume that we have plus here. What should be the answer? So what are you going to do with the power? Now, let me clear it. Unlike multiplication and division, it doesn't matter the powers. You can just do what you want to do. But when it comes to addition and subtraction, try as much as possible before it can work. What will happen to the power? You try that you work on this, you manipulate this number to give you the same power with this one. It's either you work on this one to get the same power with 6, or you work on 6 on this power to have the same power. That's the only way it can work. If the two of them are the same power, you just bring out one power and do what? Is it clear? Now the question is, how do we now manipulate them to get the power? Who can do it for us? Who can do and explain what? Who can do it fast? Oh yeah, come out fast. No get wrong. Come out. I don't see this as a question. That's what I'm doing. You just come out and do it. Let's just please, as you do it, please, if you have question, please ask. Don't, in as much as I don't see it as question, some may see it as question. Just ask so we can explain.
You check compare the quantities. This is -2.
Okay.
So to read that, you reduce this to -2. You check if it will be longer than raising this to -2. So from these two powers, now which one is easier to reduce? Is it to -2 or to 6? -2 will be easier now, because if you raise this thing to 6, we have to be.
You move from -1, -2, -1, 0, 1, 2, 3 to 6.
Which is 2.5 times 10 raised to the power of 6. So now for us to add something to this, is it right or left?
They don't know. Tell us. We don't know.
So remember, if you move to right,
Okay.
it becomes minus, right? Move to left, it becomes plus. That is positive and negative.
Okay.
If we should go like this is. Then if we should go like
Your decimal movement or shift.
this is plus.
Okay.
So now we should be moving towards the right. Is it not? No. Is it? Okay, left. Okay, this side, right? Yes. Now, which is okay, sorry. From here, 1, 2, 3, 6 plus. Sorry. What are we going to subtract from this to get? 1, 2, 3, 4. That is 0. 1, 2, 3. So 1, 2, 3. What follow for 0 now? So that's 1, 2, 3, 4, which is that is minus what?
-5.
It's for 1, 2, 3, 4. It's the first one.
The 0 before the is
No, no.
It's not there.
This one is so. This is what I'm looking at. 1, 2, 3, 4. 1, 2, 3, which is -4, right? What are we going to do? Plus or times? Sorry. So -4 plus 6.
Oh, you're getting that serious? Who has already safe? I'm not following you. Are you sure?
8 plus 8 plus 6 -2.
Okay. Wait. Let me clarify things. Look at this now. From what she said, two of them, these two powers must be the same thing. You either raise this one, or let me go. If she's not following. Now you either raise this one, you either raise this from -2 to 6, and for you to raise it, You work on the decimal place on this one, simple, to get minus, to get this to be up to 6. Or you reduce this thing to what? Minus 2 by working on decimal places here. Now, and for you to do that, look at, if you decide to work with this side, let's work with this side. I look here. If you decide to work with this side, see what will happen. See what happened here. What will you add to this 6 to get minus 2? You add minus what? 8. If you add minus 8 here now, you have minus what? 2. Is it clear now? Do I agree to this? Yes. Just add minus 8 here. It becomes 6 minus 8, which is now minus 2. Is it clear?
What if you're still working? How many zeros? 8 zeros.
8. I'm just calm down. Good morning, sir. Sir? Oh, hello. So we agree here now on this day that if you add a minus 8 here now, we have what? Minus 2, right? Now, if you change this place as you add minus 8 now, how will it reflect here? What you added there is negative. Minus 8, right? So, you get 8 decimal movements. For sure. You get 8 decimal movements. But the direction of that guys depend on the sign. Since it is negative, the direction should be what? Left. So the decimal movement will mean that you move the decimal point 8 places to the what? Left. Now if you move it now, see what you will get. See what you will, for this place to become minus 2, you start moving from here, which she has done already. You move from here. This is the decimal point. You move it to the left 8 times. 1, 2, 3, 4, 5, 6, 7, 8, and stop here. See what she did. She said for me. Remember, it's after 2 here. Everybody will move 1, 2, 3, 4, 5, 6, 7, 8, and stopped here. So this is this number now, right? So we have this are the same thing. I hope you know. That's why we call this in notation. You have put it in this form, but it's the same what? Number. Now this is, having put this one in this form, now you already now have what? This one already, true of us, plus this one. You already have 3.6 times 10 to the power minus 2 plus 0.0025 times 10 to the power minus what? 2. Remember, if you have, let me use symbols now. If you have x, a times y plus, in brackets, plus b times y. What would do you think will happen? They have y in common, right? Right? So you bring out a plus b, right? Times what? Y. True of us? True of us? Yes, because if you expand this bracket now, y. If you expand this bracket now, this is a times y, area plus b times what? Y. This is the same thing happens here. They have 10 to the power minus 2 in common. 10 to the power minus 2. So simply move 10 to the power 2 by the side. You have something like this. 3.6 times 10 to the power what? Sorry, 3.6 plus what? Plus this number, right? 0.00 blah 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 blah. 25. All times what? 10 to the power minus 2. So if you add this thing now, this is now the answer to this question. If you like, work on this one. If you see, to still give you the same what? Answer. And how can you work on this one? You can work on this one by simply, what can you do to this minus 2 to get 6? You add what? You add 8, right? You add 8. So that means you do decimal movement on this one in the positive direction, right? To the right. 8 times to 8 movement to the right. So it will start shifting from here like this to the right. After you add everything, you get the same what? And is it clear? Now this is what it's all about. Now Addition and subtraction obey the same what? Rule. While multiplication and the division have their own what? They obey the same rule. We have product rule, quotient rule. You know all those ones. You did your differentiation, right? You know your quotient rule. You know your product rule. So this one, addition and subtraction, you follow the same pattern. Now I have real life scenario, real life question I want us to look at. After that, with this, I think we have even solved more than one questions in this thing. But why I don't consider this in question. That's why I am not counting them. I want to also look at question that has to do with now look at this question. It's simple. The following products who can solve it for us? Who can try? We'll pick it up from there. You are coming? Okay. Want to solve it? I beg you. Oh yeah, come and solve for us. You got what? 4.5 what? 4.5 naira. Come and solve it, but let's see what you did. Let's see how you arrived at 4.5 naira.
He said we should determine the total savings and then the product will be 15%
Off
off
the normal price.
global price. That means for this paracetamol now, they sold it 15%. Like they gave discount of 15%. So 15% of 20 naira.
Yeah. Okay. Okay, so how far have you gone?
I'm single.
Okay, you made mistake. Okay, let's work in the area.
For paracetamol,
Okay.
15% of 20
Off. Okay, so continue. It's what?
is 3 naira.
Okay.
Then for the tablets, 15% is 1.5.
Okay.
And they sold 100 tablets
Okay.
of paracetamol.
Okay.
So if one tablet was sold, let me see, they sold one tablet is 220 naira.
Okay. Normal price.
Minus this 15%.
Okay.
Is 17 naira.
Okay.
Then for this one, 10 naira minus 1.5 is 8.5 naira.
Okay.
They sold 100 tablets of paracetamol for 17 naira.
Okay.
So for 100 tablets is equal to 17 mg times 100
Okay.
which is equal to 1.7
Okay.
Then for 50 tablets of PCM,
8.5 Nigerian naira. Yeah. No, as in for with me see now.
8.5 mg
Okay.
times 50.
Okay.
This one will be 8.5 times 50. 8.5 times 50. 425. So to get the customers total saving. They were supposed to buy it at 20 times 100, which is 2,000 mg for paracetamol, and 10 times 50, which is 500 mg of vitamin C. But instead they bought it at 17 and 425. So to get their saving, they minus this one from this one, this one from this one, which is 2,000 mg. Minus 1, which is 300.
Okay.
And 500 minus 425. Thank you, my sister. 75 mg. Then total you add it. That's 300 plus 75 is equal to 375.
Nigerian. All right. Thank you. Thank you. Please, let's encourage her, please. Chinaza, when you finish your secondary school, did you teach in the nursing school? Did you do it at all? Okay, you didn't do it. Okay. And she got, even though she took a very long process, but it's good for people. I like the way she did it. But in exam condition, don't waste your time like this. Hello, can you hear me? In exam condition, don't waste your time like this. But for the purpose of what you are doing, take or leave it. People assimilate at different level. If not, at this point, even here, at this point, you just get the answer straight. At this point, someone say, but did you understand what she did? Are you see? Okay, you can come. Yes. Actually, it says that 100 tablets of paracetamol, as in the paracetamol was sold at 20 naira per watt tablet, right? Per watt tablet. Fine. Nyawa, bia. You watch here now. Ime 20 plus 10. On here again, 30 of here. Can we get 50? Because you will still get 50. You will still get 50% of this. You will still get 50% of this. So 50% is a common factor here. So if you can get 15% of 20 naira, you can also get 15% of what? Of what? 10 naira. There's common 50% here. If you bring out that 15%, you get 20 plus what? 10. So simply look for 50% of what? 30. Answer about you multiply by what? 150. By what? 150. What will they give you? Do it and tell me what answer will give you. Just do 50% of 30. Or simply do 30 times 150 is what? And find 50%. What's the answer? This is for exams, so exams and Nekumakia. About to teach somebody. If you want to teach somebody, calm down. I like the way she did it. Because people understand that at different levels. I say she should explain what she did. What she did is perfect. I like what she did. But when you are in an exam, especially at OBJ, where you don't have time for all these long processes, go straight to the point. Here I have already talked about common. There's common 50% here. If you get 50% of 30, total tablets sold is what? As in 10 plus 20 is 30. If you get 50% of this, you multiply by total tablets. So what's the answer? It's not the answer. Huh?
50% of 10 is 4.5. Times 150
is what?
675.
Is what?
675.
C75. Konyeg. Okay. Remember, he said 50% off the what? Off the price, right? Normal price for this should be, this is 20 times is what? This times this is what? You see, this is what? 2.5, right? Good. So if you do 50% of this and do 50% of this, you add. Will he give you the same answer at 50% of 30?
Yes.
Have you tried it?
Yes.
What's the answer? What's the answer?
4.5.
4.5. Okay, I am at 4.5. The same 4.5 here. Mere 4.5 times 100 is what? 450, right? Remember, sorry to say this. Remember, you have, I don't know how strict they will be with their time in this exam. Anyway, last year was, how many hours? For the, I think they give up to 2 hours. I think they give up to 2 hours for 100 questions. But you don't know how many calculations they will bring out. That's another point. You don't know how many calculations they will say. Maybe I think I have 2009 past question. Now, what I'm doing is this. I'm trying to look for a way to, because one is to know something. The second part that fails students mainly in exam is how do you go about it when they ask you what question. This thing is simple, but one can still go to the exam hall and the person you will not be able to do what? Write it well and get the answer. Maybe because the person want to use a shortcut and mess up the whole thing, or the person want to follow the normal thing. None are one question, 2 minutes, aga. So these things are factors. At this level, I can remember when we are writing our exam, final exam, even if we work, applying together, teach us how to answer what question, not just to know the thing. Knowing something is one thing, then for exam condition, how to answer it is a different thing altogether. Knowing that this is one, I'm trying to check out something. If you do this now like this, we get 2.5, right? Yes. I will do this 15% of this. 50%. Remember, you don't need to go and start subtracting again. Ask you know 15% off. That 50% of Abgolu ego the customer gain. True of us. No need trying to go at the end. You start doing what? Subtracting again. About you. Asking na LSL to this customer at 15% off the what? Normal price. And since I at the customer making, the customer actually make 50% of that money. True of us. Straight, no need. Calculate everything and go and start subtracting again. About zero. Just get the value of 50% of this whole thing here. And that's what the customer has done what? Gain. So that's what you're trying to do. I did something here. There's a shortcut I wanted to do here, but I don't know. I said that it gave us C75. I'm trying to look at it again. Let me know why she got C75 there. Maybe there's an error in the calculation. Now, following the normal thing, if you have 2.5 here as normal thing, so just get 15% of this 2.5 answer by me. You get what I'm looking for. That's what the customer gain. Because the patient, the business, the pharmacy lost. Are you aware that you can also be asked, the question can be twisted? Are you aware that the question can be twisted as how much did the pharmacy lose? Are you aware? The question can be twisted in this form. How much did the pharmacy lose in this transaction? They lost 3.75. And how much did the customer gain? They lost for the customer to do what? Gain, even though they have future plan of gaining it in the future. But for now, in that transaction, they lost 15%. Now, if we add like this, we got what? Now, I did what I did. I added this. Agreed. Now, if we get this to be what? That 30 naira up here. 10% of this is 15 naira. So it's 3 naira, right? So half of this is 1.5, so 4.5 naira. 450 kobo, right? If you multiply 450 kobo by 100, what will it give you? On labor. So this thing as well will not work. Hello? But if you multiply it by this, you will do it individually before it will work. Something is missing here. It cannot work like that. Okay? Now that means the only way, shortest means you can use is just to establish this and get the what? This didn't take me up to 10 seconds to solve. True of us. It can't take you up to 10 seconds. This question now cannot take you up to what? 10 seconds to solve.
Can you say that the first 100 tablets of paracetamol at 20 naira, then 50% of 20 naira is 3 naira.
Okay.
Then 50 tablets of vitamin C is 10 naira. 50% is 1.5. So can you say to get the total, it just calculates 100, that's 100 parts of paracetamol multiplied by the 3 naira to get your 75, to get your 300 naira. Then 50 multiplied by 1.5 to get your 75.
Good, yes, good. I added, that was why there was an error there. I added it. You should treat them individually. This should be treated with its own proportion. This should be treated with its own. So this 3 naira here, right? Continue, 3 naira here. Or 3 naira should be treated with this. Times by 100. You want 300. This one, which how much?
1.5.
Should be multiplied by 50. You add everything up. You get your answer straight. I don't think if you actually time yourself, this meketa won't take you up to 10 seconds to solve. It will take up is to understand the question. What the pharmacy lost is what the customer gained. Okay. Let's move to another topic before we. Let's move to another topic. In your timetable, what do you have today? Sorry, in your timetable. Please help me check, please. What do you have in your timetable? Today is Wednesday, right? Fast. Let me. You have what?